Let's take a look at attention. So attention figures out how each word or token in a sequence is important to other words within that sequence by assigning them word weights or token weights or attention weights, if you will. So I want to talk about three types of attention. We have self-attention, cross-attention, and multi-head attention, and some of these are combined. You'll see that in a moment. But let's talk about the first one. Self-attention computes attention weights within the same input sequence where each element attends to all other elements. And when you see this, it basically means that as attention happens, it keeps feeding itself right back into itself, the same sequence. So used in transformers to model relationships in sequences, so words in a sequence. You have cross-attention, computes attention weights between two different sequences, allowing one sequence to attend to another sequence. This is used in tasks like translation, where the output sequence decoder needs to focus on the input sequence encoder. We have multi-head attention, so combine multiple self-attention or cross-attention heads in parallel, each focusing on different aspects of the input. So using transformers to improve performance and capture various dependencies simultaneously. So how can we look at this in a practical way for our architecture for the transformers? So here you can see that in blue where it says multi-headed self-attention. It's multi-headed because it's receiving multiple inputs. You see V, K, Q. And I believe that the Q is like for query, key is for key, and V is for value. It has something to do with like how search engines think, kind of. Like if you were to let's say use YouTube and you were to type in a query there, it would match it to keys, which would then return you back a value. So that is the best description I can give for it. It's self-attention because it feeds back its own sequence. It's going to be the same back and forth there. On the other side, we have multi-headed cross-attention. So it's multi-headed because it's receiving multiple inputs. So we have the VKQ, but it's cross-attention because it feeds sequence inputs from two different sources. Remember, it says that cross-attention is two different sequences. Well, we have V and K coming from the encoder, and then we have Q, which is actually coming from the decoder. So it's cut off here, but the idea is that the decoder is feeding itself right back into itself, and it goes through here into this one here, and then we get the Q, and it goes right there, okay? So again, it's not super important to remember this stuff. It's just to get you a bit of exposure to looking at these architectural diagrams and to see that there is a way to understand them, but they can get very involved, and it might be very hard to retain that information unless you are actually very invested in understanding and building these things, okay?